What will happen to us in the next few hundred years? Or 1,000? How will the universe end? How the heck should I know? Hey, nobody knows for sure, but we can gather all the existing theories together and find out. Good thing we've got this time projector here to check it out with our own eyes. Come here and have a look. Let's start with our own near future. In 10 years, you'll be 10 years older. High percentage of probability there. In 100 years, technology will leap forwards and we'll all become part of a web larger than the internet. We'll also finally start colonizing nearby planets, most likely Mars. Just a century from now, humans will be the first living species outside of Earth that we know of. Cool, huh? But it gets better. Hopping another 900 years forward to the next millennium, in 1,000 years, humanity will accept technology not only in their lives, but inside their bodies too. Ever heard about cyborgs? If that's too sci-fi for you, well, get ready for a bit of a shocker. That's exactly what every other human being will become in the future. And here goes. 10,000 years from today, Antares, the red supergiant star that is 15th brightest in our night sky, will explode in a supernova. This glorious event will be visible with the naked eye, even in broad daylight, if there still is a human eye to behold it. 100,000 years in the future, and many of the constellations we know will become unrecognizable because of the natural movement of stars. At nearly the same time, VY Canis Majoris, another super bright star, will explode in a hypernova, a much more powerful version of a supernova, destroying dozens or even hundreds of nearby planets and their satellites. And Earth will celebrate the distant anniversary by a supervolcanic eruption with hot magma and volcanic ash covering thousands upon thousands of square miles of land. In 500,000 years, our planet will be struck with a huge boulder from the sky, an asteroid of about 1/2 mile in diameter. If humans don't find a way to avoid the impact, it will cause mass destructions on Earth. In 1 million years, 2 out of 4 moons of Uranus will collide with each other, causing chaos on the planet. At the same time, Betelgeuse, one of the brightest stars in our galaxy, will explode, clearly visible from Earth. Just 400,000 years later, Phobos, one of Mars' 2 satellites, will break apart because of increasing gravity, and the red planet will have its own set of rings, just like Saturn. And somewhere far away, at the edge of the solar system, a rogue star called Gliese 710 will enter the Oort cloud, which is a field of icy comets marking the borders of our system. Because of this star, many of those comets might turn in Earth's direction, eventually bombarding it from space. 110 million years from now is when the sun will become 1% brighter. It will change the climate on every planet in the solar system, ever so slightly, making it hotter and hotter still. At 2 billion years mark, the sun's luminosity will make oceans evaporate on Earth. The life on our planet will cease to exist in all but the simplest forms, which will soon go extinct as well. 4 billion years from now, the Milky Way galaxy will collide with the Andromeda galaxy. Supermassive black holes in the center of both of them will get close to each other and begin merging into one, a hypermassive black hole that has a mass of billions of suns, and that will mark the birth of a brand new galaxy, Milkdromeda, or maybe Andway, and they'll have big sales conventions and try to get you to join. In 7.9 billion years, the sun will become superinflated and turn into a red giant, swallowing the closest planets, including the scalding hot piece of rock that was once Earth. But the star only does so to collapse into a white dwarf in 8 billion years. All planets of the solar system that survive this ordeal will quickly lose heat because the sun will become twice as small as it is today. In 100 billion years, the universe will stretch so far and so fast that galaxies will become invisible from each other's perspective. The universe is constantly expanding, and the rate of this stretching is growing too. Some say it's faster than the speed of light, which makes it impossible to see the actual edge of the universe by any means. In 1 trillion years, new stars will stop appearing in space. The ever-expanding universe will stretch so much that the distance between stars and galaxies is just too big. There will be no gas clouds and thus no material for new stars to take shape. In 100 trillion years, the degenerate era will begin. With no fuel to feed the new stars, they will simply stop forming at all, even if some tried it first. At the same time, the existing stars will slowly fade, turning from bright object into dwarfs, red, blue, white, and brown. In 120 trillion years, only white and brown dwarf stars will remain where normal stars have once been. All of them will have lost all their fuel, and space will be scattered with the fading remnants of stars. The universe will become a dark place to live in. Occasional brown dwarfs will collide with each other, merging into red dwarfs for short periods of time. But in the end, with no fuel to burn, those too will be extinguished, and there will only be darkness. In 1 quadrillion years, all planets will be thrown out of their orbits and sent drifting into the cold, dark outer space. Nothing will be able to live on any of those planets anymore, and nothing could reignite any of the stars in space. 1 quintillion years, and things that were once stars will also become ejected from their galaxies, wandering the empty universe for the rest of their time, which is, by space standards, not very long. In 10 to the 45th power years, even particles that make up everything material in the universe will start to decay. And when they finish that process, the black hole era will begin. Black holes will be the only objects remaining in the universe. The rest will be wiped out. But even black holes are not eternal. They will all decay too, and that will happen in about 10 to the 107th power years from now. What will remain after they disappear is almost pure vacuum, filled with tiny subatomic particles. There will be a vast, incomprehensible ocean of emptiness, until even those little things disappear too, making the universe an absolute void. Now, for quintillions of years, there will be nothing. This period is called the Dark Era, and time won't matter at this point. But then, if we leap forward an innumerable amount of years, what's this? The space seems to be moving. It's rippling. The ripples are getting bigger and wider, taking in more and more of the empty universe. But how could this even happen in the utter vacuum? Well, that's because of the false vacuum that exists alongside the real one. No one knows exactly what it is, but if you watch long enough, you'll see. Ah, there you have it. The false vacuum has just inflated and heated up to extreme temperatures, exploding in the empty space and filling it with new energy, giving life to the new universe, and possibly not even a single one. You know this event as the Big Bang. That's how our universe was born, and how it will probably be reborn after billions upon billions of years. Bottom line, right now seems to me like a pretty good time to be alive. Make sure to get outside and play some today. Work can wait, so can the universe.